In this first example, we're just being asked to rewrite the polynomial in standard form and then identify a few things about the polynomial. So in order for the equation to be in standard form, the exponents would be in decreasing order. So that means that my first term would be the 2x to the third, and then minus 4x and plus 9. Okay, so now you see that I've filled in the values in the table, which is comparable to the problem that you'll see like it in your Savas assignment. So based on these values, we can see that between -3 and -2, there's going to be an x-intercept. Because notice that the y value is changing from negative to positive. And then from -3 to around -1, it's increasing, but then it decreases, increases again, and then decreases. All right, so let's summarize. From here to here, it's increasing, and then from -2 to 0, it's decreasing. From 0 up until 2, it's increasing again. And then again, between these two x values, there's going to be an x-intercept. Okay, so we said somewhere between -3 and -2. So in order to make this a little bit easier to look at, I'm going to make my scale 1, 2, 3, and then -1, -2, -3. All right, so somewhere between -3 and -2, it's going to cross the x-axis. Similarly, between +2 and +3, it's crossing the x-axis. It's down here in negative land at -3, and then it's increasing, and then after -2, it starts decreasing until it gets to about 0, and then it's increasing again, and then there's an x-axis. So unfortunately, my program kind of made a straight line where it should have been a curve, but hopefully you kind of get the idea of how you would use a table of values in order to kind of estimate a graph, or in Savas's case, probably end up picking it out of a crowd. All right, in part B, it's asking us how we would use the graph to estimate the average rate of change over this interval. Now, I'm not quite sure what they mean as far as using the graph, but we have this table of values, and so we can use that in order to calculate the average rate of change. So remember that average rate of change is just slope, and on this interval, my x values are -2 and 0, and we found that their corresponding y values were 6 and 2. And so the slope would be 2 minus 6 over 0 minus -2. All right, so that's -4 over +2, so my average rate of change is -2. In this example, we're looking at a description, and we're going to translate that into what's happening in the graph. And so I'm going to make my x-axis labeled as such, just so I have some room to work with. All right, so the first bullet says that it's positive from -∞ to -4. So remember that the function is positive means that it's above the x-axis. So from negative infinity to negative 4, it's positive. All right, so it's doing something like that. And then also from negative 1 to 4. Okay, so I know it's going to increase and then decrease, but I don't know where it changes yet. It says it's negative pretty much everywhere else. So it's negative down here. But again, I'm not drawing the whole thing because I don't know when it changes from decreasing to increasing. And then from 4 to infinity, it's decreasing, so I know it's doing that. All right, it's decreasing from negative infinity to negative 2.67. All right, so here's about negative 2.5. So here approximately might be negative 2.67. So that's the place where it stops decreasing and then it switches to increasing. I don't know how far down this point is, and so you certainly, as I mentioned in class, you certainly could have had something like this, as long as the point where it changes from decreasing to increasing is still negative 2.67. All right, and then it's increasing from that negative 2.67 up until 2. All right, so maybe right around here it stops increasing. So there we go. And that's our rough sketch. In this example, we have an equation that models a amount of time it takes gases to inflate a balloon. All right, and X represents the number of quarter cups of vinegar. So the problem is asking us, how long does it take to inflate the balloon with 5 quarter cups of vinegar? All right, well, if they're telling us the number of quarter cups, then that means that we're plugging in 5 for X in our polynomial function. And so that's just typing it into our calculator. So in our calculator, remember in our graphing calculators, you want to be mindful of using a negative sign and not a minus sign at the beginning of the problem. And then we're plugging in 5 for X. Which is 6.26 seconds. All right, and then it's asking us, what do the X and Y intercepts of this graph mean in this context? All right, well, let's pull up Desmos and take a look. All right, so looking at this graph in Desmos, we can see that the x-intercept is the point 6.585, 0. And in the context of that problem, that would mean that 6.585 quarter cups of vinegar would inflate the balloon in 0 seconds. And the problem is asking us, do the values make sense? And no, not really. It does make sense that the more quarter cups I put in other words, the further right I go, it does make sense that it'll take fewer seconds. So we can see that from 0 to 6.585, the number of seconds it takes to inflate the balloon is decreasing, and that does make sense. But this x-intercept doesn't make sense in the context of the problem. This y-intercept would mean that at 0 quarter cups of vinegar, it would take 13.16 seconds for the balloon to inflate. Well, if there's no vinegar, then it's not going to create the chemical reaction, and so the balloon wouldn't inflate. So the y-intercept doesn't make any sense either. Okay, so the x-intercept means that with 6 point, you know what, I'm done.